Hi guys, welcome back to my channel. I'm back today with a informative video where I'm going to be explaining about blockchain fundamentals. Now, before I talk about all the boring stuff and the theory about blockchain, I just wanted to quickly share with you this screen and just remember maybe a few things for now, and we'll come back to that, especially if you are a beginner. If you're already familiar with the blockchain concepts, how blockchains work, you can probably go on and watch some other videos in my channel. So for now, uh, just think of um, this page as basically capturing the transactions that are happening on a blockchain. So all these people are basically transactions. The bigger the face or the size, it means the bigger the transaction. On the left hand side, I've got Ethereum blockchain, and then on the right hand side, I've got the Bitcoin blockchain. And you can consider this as a bus terminal. So blue blocks can be considered for Ethereum blockchain, and these orange blocks are for uh, Bitcoin blockchain. And you can see the passengers are boarding the buses. Uh, and as soon as the bus gets full, the bus or the block departs, and the next blocks get into the queue. And also you can see there are some time that what is the current transfer fee for the transactions, the median transfer fee on both networks, how many pending transactions are there on the network at the moment, what are the fees associated, and what is the block number at the top. So we'll come to that. I just want you to remember that, and you can see there are still quite a lot of people in the waiting queue. And there are quite a lot of them on the Ethereum network. Okay, so this is just, remember, you can see some blocks, different color blocks, and you've got some fees and some numbers, and we'll come back to that. Okay, so let's let's see what I wanted to basically discuss today was the blockchain concepts. Especially if you are a beginner in this area, it's better that you understand how blockchains work, what is the future of blockchain technology, and is there actually anything underlying the whole blockchain, and why there is so much fuss about Bitcoin, Ethereum, and all the cryptocurrencies, or is there more to blockchain? So it's going to be an informative lecture. I found this picture a little bit funny. Blockchains certainly don't look like this as shown on the picture, so don't hold me for that, but this is just a funny way to, when some people, you talk about blockchain, maybe that's what comes to your mind, but that's not what it is. And I'm going to explain what a blockchain is. All right, so what is blockchain? That's the first question. Yeah. So a blockchain, think of it as a, historically, if you had computer background, or if, you understand, or if you have heard of terminology called database. So blockchain is just like a database, uh, put it simple. And the purpose of, or the goal of the blockchain is to allow digital information to be recorded and distributed, across the network. But you can't edit that information. Yeah. So yeah, you can just remember simply, blockchain is a database, so it's also called as a digital ledger. And the purpose of blockchain is to distribute digital information. Uh, how it differs from a typical database is slightly different. In a typical database, the information is generally stored, in a tabular format, and the database is housed on a bunch of servers, could be multiple computers, depending on how big the database is. Whereas on a blockchain, the data is stored in the form of blocks, as I just showed you. So, and those blocks are chained together, so every block is connected to the previous block. uh, and the linkage is there for a reason, and that will come in the next couple of points. So remember that blockchain, very simply, it's a blockchain is basically it's just a database where the information is stored in blocks. Yeah. Now, different type of information can be stored on a blockchain, but the most common use so far has been, using blockchain as a ledger, as I called about a digital ledger for transactions. Ledger is something that you have like a record, right? If you are familiar with the record keeping, you have a ledger of all the items. So basically, blockchain is something similar where you have, it's a digital ledger and it has got a record of all the transactions that have happened since the time the first block was released, or since the blockchain was introduced. Um, so there are slight differences. So there is no delete option. So once the information is entered on a blockchain, it can't be amended. So these are only, you can only append the information. Yeah. So you can only add information basically, which makes them secure as well. And we'll come to that in the security and transparency and how does that whole thing work. Yeah. So each entry, which is also called a block in the database, is cryptographically linked to the last entry. Yeah. So we talked about that the blocks are linked together by a chain. So, and those blocks are basically, linked together using this method called cryptography, or this is like a code, a certain code that is developed for a security reason. So in plain English, each new entry must contain a digital footprint of the last one. So any new block that is created on a blockchain has the information of all the blocks all the way down to the very first Genesis block, as we call them. So let's, if we talk about Bitcoin network, uh, the Bitcoin network was the first Genesis block, was created, or was sort of mined by Satoshi, was the founder of Bitcoin. So any new block which we create today, it will be connected to all the way to the very first block. So that if you go back to the visual that I was showing you, you can see the current block number at the very top is 69,669,132. So this is the latest block that is currently being mined, and this goes all the way down. You see, so these are connected to the very first block, not just. So this is not just the end of the blockchain. This goes back to the very first block. Yeah. And you can, as you can see, they are all connected, and they have all these transactions that are coming, from the network. All right. So going back to the slide pack. So this hopefully is clear. So blockchain, put it simple, it's just a database. It's a digital ledger, and the purpose of it is to basically store information, and distribute the information. Now, we wanted to understand that how this decentralization concept comes on a blockchain, because normally databases are owned by companies or computers that are housed in a certain environment, maybe in a server room. There's a building there with a bunch of computers, and you have your database or your servers running and your database software is running. Whereas in a blockchain, it's slightly different. In a blockchain, the computers are not under one roof, and each computer or group of computers is operated by, could be an individual or a group of individuals or different companies. Yeah. And these computers that make up that network are called nodes. So this is a definition of a node. So basically, each element of the Bitcoin network that make up that, that sort of have a copy of the blockchain, they are called nodes. So just remember that the Bitcoin network is decentralized. It's not owned by one company. It's not owned by one organization. It has got servers all around the whole world. So it's not managed by one entity, and each of the node has the copy of all the blocks and all the transactions that have happened. So they sort of work in that way. So in a blockchain, each node has a full record of the data that has been stored on the blockchain since its inception. And this is really important concept, because that's what prevents any changes or any hacks to the data. So let's say that if one node has an error in the data, it can use thousands of other nodes as a reference point to correct itself. And this way, no other node within the network can alter the information held within it. So if I give you an example, let's say we have a hacker and he wants to alter the blockchain and steal everyone's Bitcoin from everyone else. Yeah. So if they were to alter their own single copy, let's say that they are on the blockchain, they are a node, and let's say they change the transaction and they do some funny thing, and if they alter their transaction value, it would no longer align with everyone else copy. That's first thing, because everyone have the transaction data for that transaction that has already happened. You can't change it, right? So if you try to alter it, it would get rejected. So uh, and that basically, when everyone will cross reference their copies against each other, they would see this one copy is standing out, and that hacker's version of chain would be cast away as illegitimate, and there is actually heavy fines as well if you do that. Another thing is it's impossible is that succeeding with such a hack would require that the hackers simultaneously control and alter 51% of the copies of the blockchain, so that their new copy becomes the majority copy, which is not possible. You can't alter half of the data on the blockchain, or data on half of the nodes, half of the computer. Let's say you have 1 million computers that are having a replicate or duplicate information or same information for that particular transaction. If you need to alter that, you need to alter at least 51% of those, which is, it is next to impossible. So hence it is decentralized, and it is made secure by it's a decentralized, it's people's network, so people make it secure. People who are mining the network, supporting the network, and providing the energy and all the bandwidth. Next concept to understand that whether is blockchain really secure, and how transparent it is. So because of the decentralized nature of Bitcoin's blockchain, it's decentralized, as we explained. All transactions can be transparently viewed. So there are a couple of websites. I'll show you one as well, where you can actually see the transactions, of all the Bitcoin movement, from one person to the other person, by using the blockchain explorer. So it's fully transparent. Obviously, you will not be having the identity of the individual. It will more be an address, which is not your personal name as such. It's a digital address. Um, then each node has its own copy of the chain that gets updated as fresh blocks are confirmed and added. So basically, literally, what it's saying is that if you want, you could track Bitcoin from wherever it goes. So if it was sold from one person A to B, B to C, all of that movement of that transaction would be there. Hence, it's why it's very easy to track down. Even if somebody hacked or stole some Bitcoin, you could trace it back. Um, you can trace it back from where Bitcoin was, from where it went to which person or which address, or where it was used or where it was sold. You may not be able to find out the identity, but you can track down the Bitcoins. So uh, so blockchain technology accounts for the security and trust in many ways. Firstly, as I said, the new blocks are always stored linearly, and chronologically. So they are linearly and chronologically added, so it's like a long chain. So there is nothing like coming in between. You can't sort of add information in the middle of the chain. It's always towards the end of the blockchain that you add a new block. So they are always added to the end of the blockchain. So if you take a look at the Bitcoin blockchain, you will see that each block has a position on the chain. I think the number that I showed you is 65,001 something. So every block has a unique number, and it is mined. A new block is released after a certain time by the miners, and then that block actually carries a number of transactions with it. And we'll show you that what is how does that happen, and what are the transaction fees, how many transactions can carry through a network. So this was just a quick sort of brief summary on blockchain today. I think I didn't want it to go into more technicalities, but let me just show you the blockchain explorer that I was talking about. You can see this website, blockchain.com/explorer. And basically, it is currently showing the price of Bitcoin. It is showing number of transactions, hash rate, transaction volume, etc. Mempool size is basically size of unconfirmed transactions. So any transactions, once they are submitted to the network, they go into a pool called mempool, and you can see the size of the transaction, size of the mempool, sorry, and you can see all the transactions from what is the block height or the block number, and when the block was mined, who was the miner, and so on and so forth. So you can see this transaction, for example, on the blockchain. This much BTC, for example, went from this to that person. You got some more details there as well. So again, Bitcoin mining is a separate topic in itself. I'm not going to explain that how you sort of mine the network, how much power is required, what is the consensus mechanism on the blockchain. I will cover that in a separate video. But today was just an overview. So I'll come back to this. So if you just click view on all charts, you can see an overall block size. What is the block size? So it's 1 MB. Transactions per day, 227,000 transactions, and the current mempool size in bytes. Now, this is more of an information that currently the Bitcoin block generation time is roughly 10 minutes. So after every 10 minutes, a new block is generated on the Bitcoin blockchain. So for example, if the current block is 33, there will be a new block 34, which will be created roughly in 10 minutes or 600 seconds. And basically, Bitcoin can carry an average around 300 transactions, in that block. So basically, every 10 minutes, Bitcoin network would be able to perform 3,000 transactions, which is not too fast when you compare it with for example, the Visa network or MasterCard. Visa can handle, they say, roughly around 1,700 transactions a second. And if you compare that to Bitcoin, which is 3,000 transactions in 10 minutes, that's too slow. And hence, Bitcoin at the moment has not been sort of considered as a digital cash, but it's more of a store of value coin. So if you also go for the blockchain future, you can see the blockchain technology is currently widely getting adopted by some of the big multinational companies like IBM in the food supply, where they want to basically see all the way from in the food, basically all the way from the farms all the way to the processing cycle. You can also see, you can read the article what they're doing. There's company like Walmart are already using and exploring big blockchain technology. That how can they use blockchain technology not just to transfer money, as a transfer of cryptocurrency, but what are the other use cases? So there are other use cases that are currently being worked on around logistics, e-commerce, and things like that. Also, if you see Pfizer, I'm sure all of you have heard of this name by now, given the whole COVID situation. So Pfizer is also, exploring blockchain use case in the, in the medicine industry. So blockchain, I see that this technology would grow in the future. I'm quite bullish on, the blockchain as a technology evolving. And I do see there's going to be a lot of jobs in the future as well for blockchain experts, companies going for blockchain experts. And also it's really good that if you get into blockchain, artificial intelligence, and all that, because that's the future, where everything is headed. So just quickly, just to sort of wrap up things on the transaction network. So as I said, just if you go back to this one, you can see on the Ethereum network there are a lot of transactions pending. 75,000 by the looks of it. And you can see Bitcoin last block was only created 7 minutes ago. So as I said, every roughly 10 minutes there's a new block created. Ethereum network is quite congested and it's quite expensive compared with Bitcoin Lightning Network. So currently you can see, if you see the very first bus, this is like the VIP bus, because this is where all the heavy fees are. So anyone who is willing to pay heavy transaction fees on the network, his transaction will be processed immediately. So if you click on this, you can see that this block, which is the first one, was having confirmation time of 13 seconds. That's really fast, and similarly, if you see, the number of transactions and the gas price. The gas price is basically the transaction fee. It's measured in GUI, which has it has an equivalent value in Ethereum. So, and these are all the transactions coming from different areas. So, for example, this is from Uniswap, which is a decentralized exchange. This is also MetaMask. This is, I think, I don't use this one, but this is 1inch. And there are some other, transactions coming from other networks. And as I said, if you are willing to pay the premium, you get the first bus. If you're not willing to pay, you have to wait in the waiting line, and then you can actually get one of the bus maybe with a lower fee. The transaction might take up to 2 hours to go through Ethereum network. So hopefully in the future, when the blockchain technology on Ethereum with Ethereum 2.0 upgrade completed, these things, the transaction fees and the processing time will definitely improve. But for now, I would say the Bitcoin is slightly better when it comes to transaction speeds and the fees. There are other blockchains as well: Monero, Bitcoin Cash. There's Litecoin, but obviously it's not on this website. But generally, you can see Bitcoin. You can see the confirmation time is 10 minutes in this case, and the block number is 691134. So all these transactions would queue up as soon as this relieves. The next block would be, they would get distributed. So as I said, each of the information is synced across the whole network. So each of the transaction copy of that is maintained on the whole blockchain. So you can't really alter that. That's pretty much it, guys, from a overview of what blockchain is, or how the transactions happen roughly on the blockchain. Just quickly to explain how is the security mechanism, and how the whole decentralization comes to blockchain. In the next video, I'll be talking about the consensus mechanism on Bitcoin. How does proof of work, and what is the difference between proof of work versus proof of stake, because there's slightly different consensus algorithm. What is smart contracts on Ethereum network, and what is the future of smart contracts, and how it's gonna sort of change the way the whole thing works, around the finance, around real estate, and there are some other use cases of smart contracts as well. If you like this video, guys, please like the video, and if you got any questions, comments, please drop your comments. And yes, please do subscribe my channel. Thank you for your time today. Bye.